Hello, my shimmering stars. I welcome you all to this amazing platform of PW English. Students, I welcome you all to your Nexus Batch. And today we are going to start with your chapter S block elements. And this is going to be your lecture number 2. I hope so, students, you have seen the previous class and you have done a lot of questions. Even you have read NCERT. But if not, students, please do that, because for inorganic chemistry, the more you practice, the more you're going to explore. Though we have completed each and every topic, but I want you people to practice a lot of questions. Yes? Okay. So now, ma'am, what are we going to do in this particular session today? So as I told you in the previous class also, we are going to divide S block elements, in such a way that first of all, we'll be completing group number 1, then group number 2, and then the compounds related to both of them. So we have already covered group number 1. Now it's turn to do group number 2, right? Okay. So now let's start this class with a beautiful smile. So basically this is your lecture number 2 for the chapter S block elements. Now what is the sequence? How are we going to proceed in this particular class? So we are going to start with the questions based upon the group number 1 that we have done yesterday. And after that we'll be doing group number 2 in detail, again in the same way. The properties, the introduction, the physical and the chemical properties in the same way as we did for group number 1. Let me tell you, students, when you will be doing group number 2, no, almost each and everything is so similar with group number 1 properties that you will feel like, oh, this is so easy. Yes, it is. Okay, so now let's start with the question based upon your group number 1. First of all, I will be providing a timer over here of about 30-45 seconds or 1 minute, so that you can get an idea that how questions are generally asked and you can solve that question in a particular time bound, right? Now, I'm going to put a timer over here and I'm going to read the question for you people. As compared to potassium, sodium has A. Lower electronegativity, B. Higher ionization potential, C. Greater atomic radii, or D. Lower melting point. So I'm giving you 45 seconds for this question. Just think it very carefully. They have just taken all the properties over here, right? Electronegativity, ionization potential, atomic radii, melting point. So just think, students, compare, potassium and sodium. So you can write the complete group and then compare all the properties. You will get your answer. Yes? Okay. Now you have only 20 seconds left, everyone. So it's tick, 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 tick going on, right? So it's basically 10 more seconds to go. Yes, and then we are going to solve the questions. I hope so you answer this question right, okay? Yes, so the timer is stopped, students. Now let's discuss about it. Basically, we are comparing what? We are comparing, ma'am, potassium and sodium. Now we very well know what are the group number 1 elements, basically. Lithium, sodium, potassium, rubidium, cesium, and francium. Though francium is a radioactive element, so I'm not including it. Even hydrogen we have studied separately, so we are not including that. Now coming to potassium and sodium, that means we have to talk about both of these elements over here, right? Sodium and potassium. Now let's talk about first of all the electronegativity trend. See what is going to happen. When you're moving from top to bottom, that means from lithium towards cesium, what do you observe? That, ma'am, number of shells, basically number of shells increases. If number of shells are increasing, what happens to electronegativity, ma'am? It is going to decrease. Why? Because if number of shells are increasing, size is going to increase. And if size is increasing, electronegativity will decrease. Why? Because electronegativity, if you don't know, students, is inversely proportional to size. It is inversely proportional to size, everyone. Clear? So now, what is electronegativity if you don't know? Though we have done in 3rd chapter, but electronegativity basically is the tendency to attract shared pair of electron towards itself. This is what is electronegativity, right? So as size increases, electronegativity is going to decrease. That means if electronegativity is going to decrease, what is the order for electronegativity? Right, lithium will have the highest, then sodium, then potassium, then rubidium, and then the cesium, right? Because this is going to be the order. Now we are comparing potassium and sodium. So sodium has higher electronegativity than potassium, so this is the incorrect statement. Let's see the B part now. In B part, they are talking about ionization potential or ionization energy. Now, see, what is an ionization potential or ionization energy if I'll talk about? Now, students, understand this very basic key point. It's very, very simple. Again, if size is increasing, ionization energy or ionization enthalpy will also decrease. It is the same way that ionization energy is also inversely proportional to size. If size is going to increase, ionization energy will also decrease, right? So the order, if I have to write over here, is again going to be the same. It is going to be lithium will have highest, then sodium, then potassium, then rubidium, then cesium. Now, if you don't remember what is ionization enthalpy, basically it is the minimum amount of energy required to remove one electron from the outermost shell. Okay, so basically when the size is small, the attraction between nucleus and the outermost shell electron is stronger. Okay, and if the size is a larger one, okay, atomic radii is the larger one, so the distance from the center to the outermost electron is larger. And if you will give very less amount of energy to the larger radii, it can be taken away very easily. But the one which contains a smaller size, you have to provide a lot of energy in order to take that one electron from the outermost shell. That means smaller the size, higher the ionization energy, right? So over here, sodium will have more than potassium, so sodium has a higher ionization potential. This is the right statement, students, for this particular question. It is the right statement. Yes, everyone. Now the next C option also, let's discuss about that as well. C says greater atomic radii. Now only we have told that number of shells increasing, so basically size is increasing. So what is going to be the size order? It is very simple. Lithium will have least, then sodium, then potassium, then rubidium, and then cesium. So cesium will have the highest one, no? So they are saying sodium basically has lower size than potassium. They are saying it has greater atomic radii. So this is the incorrect one. Atomic radii is the distance from the center, that means from the nucleus to the outermost shell electron, right? Now comes the last part, that is lower melting point. And if you remember, students, I already told you that melting point basically is going to decrease down the group. And if it is going to decrease down the group, it will have the same order as that of ionization enthalpy or electronegativity. That means sodium will have highest than potassium. So sodium should have highest, not lower. So this is also the incorrect statement. Hence, what is the answer that we got over here? Answer comes out to be option number B over here. Answer is your option number B, my dear students. Clear, everyone? Shall we move on to the next question now? Clear, easy. I feel that you all have written this trends also. If not, students, do write it, okay? Let's move on to the next question. Next question is, which of the following statement is correct regarding the alkali metals? Okay, correct regarding the alkali metals. For this one, I would give you 1 minute approx. Okay, just think about it, students. Now I'm reading the options over here. The timer is also started. So it's basically A option is cation is less stable than the atom. B option is cation is smaller than the atom. C option is size of cation and atom is the same. While D option is cation is greater in size than the atom. So basically these are the 4 options for this particular question, and they are asking about the alkali metals. That means about your group number 1 only. And here, if you'll observe, they are talking about the size of the cation as well as the size of the atom. That means you have to tell about ion and atom. So think about it, students. Though I have already told you, the order for the ion and for the atom, I feel you also know this answer. 15 more seconds, students, and then I'm going to answer this particular question to you all. Yes, everyone, let's hope for the best. Yeah. So now let's discuss one by one. See, the very first part is cation is less stable than atom. Cation is smaller than atom and the size comparison is given. Now let's talk about sodium. Let's take an example of sodium. Now sodium, basically how it is going to form a cation. When it will liberate one electron, it will form a cation, that is Na positive. So this is basically the cation formation, how cation is created. Now we very well know that sodium has an atomic number 11. That means how many electrons are there? It is neutral species, so it basically has how many electrons, ma'am? It basically has 11 electrons, right? And if I'll talk over here in the case of Na positive, how many electrons are now left? When it is losing one electron, it will be left with only 10 electrons, right? So if I have to write the electronic configuration for both the cases, in the very first case, what is going to be the electronic configuration, ma'am? 1s2, 2s2, 2p6, 3s1. So this is the electronic configuration for only sodium. 1s2, 2s2, 2p6, 3s1. How many? See, 2 plus 2, 4, 4 plus 6 is 10, 10 plus 1 is 11. So we have filled 11 electrons. Now let's talk of Na positive. It is going to be 1s2, 2s2, 2p6. Now here it is 3s0. That means how many electron? 2 plus 2, 4. 4 plus 6 is 10. Done. Let's draw their structures over here. If I'll draw the structure of sodium, of Na over here, which contains how many electrons? 11. It has how many shells? First shell, second shell, third shell, right? So this is nucleus. This is first shell. This is second shell. And this is third shell. This is of sodium. Let's create Na positive over here. How many shells in Na positive? First shell containing electrons, second shell containing, third shell contains 0 electrons, right? So only 2 shells. Nucleus, first shell and second shell, right? Now students, let's fill all the electrons over here. Okay. So in this case, sodium, we have 1s2, 2 electrons over here. Now we have 2s2, 2p6. Second shell contains 2 electrons of S, 6 electrons of P. Total 8 electrons. So 1, 2, 3, 4, 5, 6, 7 and let's say 8. Now the third shell contains only 1 electron. Only 1 electron. Let's talk about Na positive. So it contains 1s2. That means the first shell contains only 2 electrons. And the second shell contains 2 electrons of S and 6 electrons of P. That means 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8. Right? So now if I'll ask you, what is the order of size? Now see students, it is clearly, you can just tell with the help of diagram only. The distance from the center to the outermost shell electron. Now this is outermost shell electron. So distance from here to here is basically your atomic radii. And over here, this is outermost shell electron. So this is the radius. Which radius is more, ma'am? This radius is more. Very simple. Very simple. That means atom will have a larger radii than the ion. And basically here we are talking about cations, no? It is having a larger radii than the ion. Here even you can write it in a better way that atom has more size than the cation. So among the following, which is correct statement? Cation is smaller than atom? Yes, ma'am. Answer is going to be option number B, that cation is basically smaller than the atom. Clear everyone? Clear everyone? Simple, easy question. Okay. Let's move on to the next question now. Valence electrons in the alkali metals is how much? I feel only 10 seconds for this question. Only 10 seconds. Now see students, I told you valence electrons. What are the valence electrons? The outermost shell electrons. In alkali metals, we have a general electronic configuration. General electronic configuration, that is NS1. So we have only one electron in the outermost shell. That means its valency is going to be 1. Its valency is going to be what, ma'am? 1. Simple, easy. Okay, let's move on to the next question. Magnitude of which of the following property of alkali metal increases with increase in atomic number? Z basically is your atomic number. I am giving 1 minute for this particular question. This is basically atomic number. Atomic number. A option is electronegativity, B option is ionic radii, C option is first ionization energy, D option is melting point. Let's see, students, whether you are able to tell this answer or not. Everyone, let's hope for the best, whether you know this answer or not. 29 more seconds till then I'll drink a glass of water, everyone. I hope so. You are able to answer this particular question. Okay. Now see, students, let's write everything again. Lithium, sodium, potassium, rubidium, cesium, francium is a radioactive element. We are not included it. Now see, students, from top to bottom, we are talking as, Z increases, atomic number increases. What will happen then? That means number of shells is increasing first of all. If number of shells increasing, ma'am, size will increase. Very basic part. So what is the order for size? Lithium will have smallest, then sodium, then potassium, then rubidium, and at last is cesium, right? This is the order of size, and this is same for atomic radii. Size, that means this is order for atomic radii as well as for ionic radii. It is the same order that atomic and ionic radii basically are going to increase, right? So the next is, the very first is electronegativity they are discussing. Let's discuss electronegativity. If size is increasing, but obvious, what is going to happen to electronegativity? It will decrease. I've already told in the previous question. If electronegativity will decrease, lithium will have highest, then sodium, then potassium, then rubidium, then cesium, right? So electronegativity will decrease, right? They are saying magnitude of which of the following property of alkali metal increases with increase of Z. With increase of Z, electronegativity is decreasing. So this is incorrect. Now the second is ionic radii. I already told you, if Z is increasing, ionic radii will increase. That means this is the right answer. This is the right answer. We already got our answer. That is option number B. But let's see the C and D part as well. It is first ionization energy. Now let me tell you, if I'll talk about ionization energy, it is also inversely proportional to size. Ionization energy will also decrease. Already told you why it will decrease. Smaller the atom, greater the force, and large the ionization enthalpy given, right? Larger the energy provided. So that means smaller the size will have the largest ionization enthalpy and the greater one will have the lowest one. So it is again going to decrease. It is going to be the same order as that of electronegativity. They are asking it should increase. No, it should not increase. Not possible. Now the next part is about melting point. This also we have already done about melting point. That from top to bottom, if you're coming, melting point is also going to decrease. So with increase in Z, melting point is also decreasing. They're asking which is increasing. So answer is going to be option number B. I hope so. This question is clear to you. Let's proceed towards the next question now. Next question is the alkali metal that reacts with nitrogen directly to form nitride is which of the following? Is which of the following? 10 seconds for this particular question. Only 10 seconds for this particular question. So let me tell you, students, answer is lithium. Answer is what is lithium. In the previous class, I have mentioned this and I have told to write down this key point that lithium is the only one alkali metal that reacts with the nitrogen and creates lithium nitride, Li3N, lithium nitride. Clear, everyone? So answer is going to be option number A. Let's see the next question. Which of the following has the smaller size? Now, this question, students, is your first homework question for today's class. Now, we have done one question at the back for the size concept, the order of size. Now, this is for you. Which of the following has the smaller size? Which of the following has the smaller size? The first homework question. I guess you all have written this. That's great. Now comes the next one. Now, this is also your second homework question for today. That is, which alkali metals is most metallic in character? Which alkali metals is most metallic in character? Okay. Now, students, we are going to start with our topic of today. That is going to be group number 2. I hope so you have revised now the question parts and you have revised the group number 1 with the help of questions only, right? So, let's proceed with now group number 2. Group number 2 students generally are referred to as alkaline earth metals. What are they called? They are called alkaline earth metals, because they are derived from earth crust first of all, and they are basically alkaline in nature. Their oxides and hydroxides are alkaline in nature. Now let's talk about what are the members of group number 2. What are the members of group number 2? That is beryllium, magnesium, calcium, strontium and barium. Okay, and even we have radium, so I'm going to write it again. Okay, I'll write it small. Beryllium, magnesium, calcium, strontium, barium and then the radium. Okay, let me show you where do they lie in the periodic table, students. Okay, let me show you where do they lie in the periodic table. So it is beryllium, magnesium, calcium, strontium, barium and radium. These are the group number 2 elements which lie at the left hand side of the periodic table. Now coming back over here, how do we write the atomic numbers of them, ma'am? It's so very simple. In the previous class also I told you. First of all, write the atomic number for beryllium and then use the magic trick of 8, 8, 18, 18, 32. Use this magic trick over here to write down the electronic configuration. For group number 1, we use 2, 8, 8, 18, 18, 32. Here we will be using 8, 8, 18, 18, 32, right? Now we have 4. 4 plus 8 is going to be what, ma'am? 12. 12 plus 8 is going to be what, ma'am? 20. 20 plus 18 is going to be what, ma'am? 38. 38 plus 18 is going to be what, ma'am? 56. 56 plus 32 is going to be what, ma'am? 80. So these are basically the atomic numbers for your group number 2 elements. Clear, everyone? Let me tell you that magnesium basically has a characteristic in the chlorophyll process. And then if I'll talk about calcium, basically in the teeth, right? And so basically these two both have a greater significance in comparison to the other members of the alkaline earth metals. Now, as I've told you that they are referred to alkaline earth metals, but basically beryllium is not referred to as alkaline earth metal. Beryllium, I guess this is written over here, right? So let's see. Basically, the group 2 elements comprises beryllium, magnesium, calcium, strontium, barium and radium. They follow alkali metals in the periodic table. After alkali metals, they are alkaline earth metals. These except beryllium are called alkaline earth metals. Though they have characteristics that are similar to the alkaline earth metals, that means other than beryllium. So beryllium basically is not alkaline in nature, it is amphoteric in nature, but yes, it is derived from earth crust. So it comes under the category of group number 2. It also exhibits similar properties with group number 2. Clear? Now basically one more thing, radium is a radioactive element, so you can put a star over here. Clear? Okay, now let's proceed to the next part, is about electronic configuration. So students, for alkali metal, the general electronic configuration was NS1 and for them it is going to be NS2, right? Let's start. Let's write it. Beryllium, magnesium, calcium, strontium, barium and radium. Now see students, what you have to do is, general electronic configuration is NS2. See, in beryllium, if I have to write, it is 1s2, 2s2, right? So from here, in here, beryllium, N value is 2. Here N value will be 3. Here N value will be 4. Here N value will be 5. Here N value will be 6. Here N value will be 7. So N basically represents your shell number as well as your period number. Right. Now another thing, what is this NS2? This is the outermost shell electronic configuration. This is the outermost shell, second shell, so we have written. For magnesium, if you have to write complete, you can write 1s2, 2s2, 2p6, 3s2. See, 2 plus 2, 4, 4 plus 6, 10, 10 plus 2 is 12. So this is outermost shell configuration. No? Similarly, in calcium, outermost will be 4s2 because n value is 4. In strontium, it will be 5s2. In barium, it will be 6s2. In radium, it will be 7s2. Clear everyone? So this is the electronic configuration with regard to alkaline earth metals. Done? Okay, ma'am. Okay, ma'am. Let's start with the atomic and the ionic radii concept, students. Okay. If I'll talk about the atomic and the ionic radii, what happens? We basically know it's beryllium, magnesium, calcium, strontium, barium, and radium. So what happens from top to bottom? Ma'am, from top to bottom, number of shells increases. If number of shells are increasing, students, very simple, atomic and ionic radii will also increase. Why? Because the distance from the center to the outermost shell electrons increases. In beryllium, we have n is equals to 2. Here we have n is equals to 3. Here we have n is equals to 4. Here we have n is equals to 5, 6 and 7 respectively. That means shell number is increasing. If I have to draw beryllium, it is first shell, second shell. If I have to draw magnesium, it is first shell, second shell, third shell. If I have to draw calcium, it is first shell, second shell, third shell, fourth shell. Right. Similarly, if I have to draw strontium, so it is first shell, second shell, third shell, fourth shell, and then the fifth shell. So as you can clearly observe that the distance from the center to the outermost shell is basically increasing. That means the atomic radii will increase. Right, everyone? So atomic radii increases from beryllium to radium due to addition of an extra shell of electron to each element. Simple. Now, atoms of these elements, although fairly large, are smaller than those of the corresponding elements of group number 1. That means if I have to compare group number 1 and 2, see, that means we are moving from left side to the right hand side in the periodic table. And let me tell you, at this particular time, from left hand side to the right hand side, nuclear charge will increase. If nuclear charge will increase, no, size will decrease. That means group number 1 will have greater size than group number 2 elements. Okay. So basically they are smaller than that of group number first. This is what I've told you, because more the nuclear charge, lesser the size. Now, what is a nuclear charge? Nuclear charge is the charge exhibited by the nucleus on the outermost shell electron. For example, if nuclear charge is larger, outermost electron will come inside, the size will decrease. If the nuclear charge is not stronger, it will go apart, size will increase, right? So now, let's talk about the next property, that is ionization enthalpy. What is an ionization enthalpy? Ionization enthalpy basically is the minimum amount of energy, required to remove one electron from outermost valence shell of an isolated gaseous atom. Okay, the energy given in order to remove one electron from the outermost shell is basically ionization enthalpy. And the trend is very, very simple. If I'm going to write beryllium, magnesium, calcium, strontium, barium and radium, from top to bottom, students, size is increasing. So ionization enthalpy will decrease because they are inversely proportional to each other. Lesser the size, more the attraction. So more energy will be given to remove the electron. That's why more the size, lesser the energy will be given, right? So more the size, less ionization energy. Alkaline earth metal possesses smaller size and greater nuclear charge than the alkali. Now they're comparing with group number 1. Let me tell you that also. If I'm writing group number 1 and group number 2 over here, see, from left to right, we know that nuclear charge is increasing, so size will decrease. Now, if size is decreasing, ionization energy and size is inversely proportional, so ionization enthalpy will increase. That means group number 2 will have the highest ionization enthalpy. So the alkaline earth metal possesses smaller size. They have small size, I told you in the previous part, and greater nuclear charge than the alkali metal. The electrons are more tightly held, and hence the first ionization enthalpy is greater than that of alkali metal. See, this is what I have written now. They have the highest ionization energy if compared to group number 1, right? Now, the second ionization enthalpy of the second group elements is less than the second ionization enthalpy of the first group. Why is it so? Because see, they contains ns2 and it contains ns1 basically, right? This was stable configuration, right? Let me tell you this now. Let me explain you this part, students. See, now in group number 2 we have ns2 configuration. In group number 1 we have ns1. So basically we have 2 electrons over here. Here we have 1 electron. This is stable configuration, so you have to give a lot of energy to remove electron from this, no? So it has first ionization energy value more. First ionization energy refers when we remove 1 electron. Now let's talk about the second ionization energy. That means you are removing the second electron. Now if you have removed 1 electron, basically it is, ns0. Now over here, if I'll talk over here, it is like this. It is like this. Now see here, if I'm taking a case of, for example, of sodium, right? So what is going to happen? Let's talk about the case of sodium. Now you've removed 1 electron, no? If you have removed 1 electron, I'm taking a case of sodium and magnesium. Let's take a case of sodium. Sodium, when we have removed 1 electron, it is going to be 1s2, 2s2, 2p6. And when magnesium has lost 1 electron, it is going to be 1s2, 2s2, 2p6, 3s1. On losing 1 electron, now we are going to remove 1 more electron. Now this is a stable configuration. 6 electron, 1, 2, 3, 4, 5 and 6. Here it is basically 3s1. So this is the stable. Now you have to give a lot of energy to remove 1 electron from the stable. So second ionization enthalpy of group number 1 will be more than the group number 2. Okay. Second ionization energy of group number 1 is more than group number 2. But first ionization enthalpy of group number 2 is more than group number 1. Clear, everyone? Now see, the second ionization enthalpy of the second group elements is less than the second ionization energy of the first group elements. Non-radioactive metal of the second group having least first ionization enthalpy is barium. Okay. Now this is the order of the first ionization enthalpy. I told you ionization energy will decrease down the group. Size will increase, ionization energy will decrease. Size will increase, ionization enthalpy will decrease. Right, everyone? So beryllium will have highest, then magnesium, calcium, strontium, radium and barium. Okay, clear, everyone? Yes, everyone. But they have told you the first ionization enthalpy is least first ionization enthalpy basically is going to be of barium. Okay. Now let's see, the next part is hydration enthalpy. Let's talk about what is hydration enthalpy. But before that, I would request everyone to please kindly write down each and everything that is provided over here. I hope so, students. Each and every one of you have written this. Okay. Now let's start with hydration enthalpy. In the previous class also I told you hydration enthalpy is basically when our cation is going to react with water. It is going to create a bond with water. At that amount of time, the energy released is hydration enthalpy, right? So basically, like alkali metal ions, hydration enthalpy of alkaline metal ions also decreases with increase in ionic size down the group. Okay, so basically this is going to be the order, right? Now this is beryllium plus 2. So basically here, now see what happens. It will have the highest one because it is decreasing down the group, right? Hydration enthalpy of alkaline earth metals are larger than those of alkali metals. Here plus 2 charge is not written, so please write down that as well. Yes, everyone, and by chance it is written 2 over here. So it is beryllium plus 2 will have highest, then Mg plus 2, then Ca plus 2, then Sr plus 2, then barium plus 2. So the hydration enthalpies of alkaline earth metal ions are larger than those of alkali metal ions. Thus, compounds of alkaline earth metals are more extensively hydrated than the alkali ones. Example they have given you such as MgCl2, CaCl2, the hydrated form of that. While NaCl and KCl do not form such hydrates, right? So this is the comparison with group number 1 as well. Now let's talk about the physical properties, students. Talking about the physical properties, again we are going to talk about what? That all alkaline earth metals are silvery white. They are silvery white. They are lustrous and they are relatively soft. Okay. But harder than the alkali ones. Relatively soft, but harder than the alkali ones. Now, the hard nature will be explained with the help of the valence electrons. See, hard nature can be explained with the help of valence electrons. Why? Hard nature refers to the metallic bonding. It refers due to metallic bonding. And in metallic bonding, the bonding is being observed between the kernels and the free electrons. In group number 1, we have only one valence electron. In group number 2, we have two valence electron. So when in group number 2, we have two valence electron, that means it is going to do more melting point. It will be having, metallic bonding more in comparison to the, the group number 1. I'm talking about metallic bonding. Hard nature is explained by metallic bonding. Metallic bonding exhibits between kernels and free electrons. Group number 2 will exhibit more because it has more electrons, right? Now in comparison to alkali, they are harder. The melting point and the boiling point of these metals are higher than the corresponding alkali metal. This also you should remember. This is higher one, right? Due to the smaller size, but the trend is irregular. If you'll observe the trend, it is irregular. If you'll see the melting point and the boiling point order, what do you observe over here? That, see, beryllium basically, if you'll see, will have the highest one and will go basically over there. And if you'll observe it very carefully, so it's magnesium, calcium, strontium, barium, and then it's beryllium. The radium we are not including, but because it is a radioactive element. So the order is going to be like this, and after that we have beryllium over here, right? So this is going to be the melting point basically order, right? Now students, let's move on to the next part, that is flame test. Now in flame test or flame colorization, what I told you in the previous class, if for example we provide some flame, so the electron from the lower ground state will move on to the excited state, and while coming back it is going to liberate some of the radiations and then it imparts color, right? So now this is what is a flame test. So salt of alkaline earth metal, except that of beryllium and magnesium, produces characteristic color to the flame. Now in this case, if you remember in the previous part, in the alkali metals, each and every element was imparting some color. But I told you students, in group number 2, I'm going to tell you there are some elements which do not impart any color. So that is beryllium and magnesium that do not impart any color, okay? This is due to the easily excitation of electrons to the higher energy levels, okay? Why other impart? This is due to the reason that electrons are basically traveling from lower to higher energy and then coming back, they are imparting it, okay? So see, beryllium and magnesium atoms, due to their smaller size, what is the reason? They have given that they have small size. Moreover, they bind their electrons more strongly. If they have smaller size, no, nucleus will bind electron more strongly. It won't allow the electron to move from lower state to the higher state. And if it won't allow the movement of electron from the lower to the higher, so it is not going to impart any color. Hence, they possesses the highest excitation energy and not excited by the energy of the flame to higher energy state. No color is produced to the flame by beryllium and magnesium. Remember, put a star over here, students, from because in group number 1, each and every element imparts color. In group number 2, beryllium and magnesium is an exception. Talking about no flame colors in with regard to beryllium magnesium, but with regard to calcium, it's brick red color. With regard to strontium, it's crimson red color. With regard to barium, it's apple green. Now this is also asked a lot of time, right? Now talking about electrical and thermal conductivity, the alkaline earth metals are good conductors of heat and electricity. So this is also a knowledgeable thing which I feel you all should know. Moving on to the next characteristic, we have electropositive character. Why they have electropositive character? Because they can create cations by losing electrons, so they can exhibit as electropositive character. What are electronegative character? When something gains electron, that is electronegative character. Electropositive, when it loses electrons, so it has 2 electrons in the valence chain to be loose, so it is electropositive in nature. Due to their larger size and comparatively low ionization energies, the alkali metals are strongly electropositive element. On moving down the group, the electropositive character is going to increase. Now this is very, very important part that you should know. Clear? Okay, ma'am. Coming to the metallic character now, right? The metallic character. The alkaline earth metals are metals and their metallic character increases down the group. It will increase. Metallic nature is due to low ionization enthalpy, okay, which decreases down the group. We have seen no ionization energy is going to decrease. Why? Because size is increasing. So metallic character will increase, right? Now, see students, always remember metallic character will increase down the group. So the most metallic one is going to be what? Your radium. After that it's barium. So basically if you'll go down the group, no, if you'll see, so radium is basically a radioactive metal. Yes everyone. Coming to the chemical properties, the chemical properties of the alkaline earth metals are comparable to those of alkali metals. Now why? Because see, they have a smaller size, they have a greater charge, high ionization energy, and they're much less reactive than the alkali metals. Okay, so now let's talk about the chemical properties. We are going to start with the very first chemical property, that is going to be your what, ma'am? That is going to be action in air. Right, everyone? Now, if I'm talking about action in air, that means I'm going to react it with O2. Very simple thing. Now, this thing you've already done. Already done. In the previous case, we did that it forms monoxide, peroxide, superoxide. So, same is going to happen in this case. But over here, what happens is basically they are going to form your peroxides. If I'll talk about the case of barium, let's talk about the case of barium. So barium basically will react with O2 and first will form BaO, a simple oxide, BaO. And then it on reaction with a greater temperature, a higher temperature, when you provide a higher temperature, it is going to form your what? The peroxide state. It will form BaO2. Okay, so alkaline earth metals have less reactivity than alkaline metals is evident by the fact that they only show only slowly oxidized on the exposure of your air, exposure to air. Coming to the next part is action of halogens. So it is going to react with halogen, that is fluorine, chlorine, bromine, iodine. What it is going to form? C. This is basically M, this is X. Halogen have a partial negative charge, while now alkali metals will have +2 charge because it has 2 electrons. No, to be, they can lose 2 electrons. So now when we are forming compound, their charges will come at the base. M will hold the charge of X and X will hold the charge of M, and positive and negative won't be written, right? So mx2 will be created. Mx2 kind of compounds will be created. Moreover, students, let me tell you now a very interesting part, that the compound of beryllium is so impossible with halogen that we need to do a certain reaction. So basically beryllium halides are covalent while the rest one are ionic. Okay, that's why you can easily draw the compound. Moreover, the ionic compounds can dissolve in water and conduct electricity in aqueous solution and in molten state. Okay. Now see, students, now over here if I'll see that the solubility of halides except fluorides decreasing on moving down the group. Fluorides are almost insoluble in water except BeF2. Okay, the next part, thermal decomposition of basically this compound is the best route for the preparation of BeF2 and BeCl2. I told you, beryllium related halogen compounds is difficult to prepare. So in order to prepare that, you have to react it with oxide of beryllium and then react it with carbon and take the halogen that you want to create. Okay, so basically halide that you want to create. So I'm taking Cl2, it occurs in the presence of 600 to 800 Kelvin and I am obtaining BeCl2 and carbon monoxide is released. Now students, comes the next part, that is action of hydrogen. In this case also, see, BeH2, that means beryllium hydride is somewhat difficult to be prepared. Okay, so all elements except beryllium combine with hydrogen to form hydrides, that is MH2. Right. Now BeH2 can be prepared by the reaction of BeCl2 with LiAlH4 with lithium aluminium hydride. So when you're going to react BeCl2 with lithium aluminium hydride, you are going to get BeH2. BeH2. Okay, so beryllium and magnesium hydride is covalent while other hydrides are ionic in nature. Clear? So that means with regard to beryllium, a lot of questions can be asked. So please pay a huge attention over here. Coming to the next part, with dilute acids. That means with H2SO4 or with HCl. See, when metal reacts with H2SO4, it will liberate MSO4. Why? Now this basically, alkaline earth metal holds +2 charge. SO4 holds -2 charge. So what kind of a compound can be created? MSO4 kind of compound can be created, liberating H2. Now when it reacts with HCl, now see students, basically M+2 Cl negative. So what it is going to create? It will form M1Cl2. So MCl2 is created, right? Now the reactivity of alkaline earth metal increases on moving down the group. Remember this part. Reactivity is inversely proportional to stability. More the reactivity, less it is stable, right? So this could be related to increase in electropositive character from beryllium to barium. Thus beryllium reacts very slowly. Magnesium reacts rapidly with calcium, strontium and barium react respectively. Okay. Now we have reducing nature. In the previous session also, when we were talking about alkali metals, we were talking about the reducing nature. In the same way, alkaline earth metal have 2 electrons outside the noble gas configuration. Now due to their larger size and low ionization enthalpy, they can easily lose the 2 electrons, the electrons, and hence can undergo oxidation. Now see, metals basically can form cations, so it can lose 2 electrons and can form what? M+2. Clear everyone? M+2. So basically, what you observe over here, they are stronger reducing agents. Why? See students, from here its charge is 0. 0 to +2 charge. Oxidation number is increasing. What is the oxidation number? Oxidation number basically is the formal charge in any element. And from 0 to +2 number is increasing, oxidation number is increasing. That means this is an oxidation reaction. In other terms, you can also understand if it is losing electrons, loss of electrons is oxidation. So that means basically they are acting as a stronger reducing agent. The one that does oxidation is a stronger reducing agent. The one that does reduction is a oxidizing agent. Clear? Okay, let's see the next part, that is solution in liquid ammonia. So what happens, like alkali metals, alkaline earth metals can dissolve in liquid ammonia. In the previous case also we discussed, giving deep blue black colored compound. So this is an important part from which they can ask you question, right? Now when the metal ammonia solutions are evaporated, okay, hexaaminoates can be formed. So this is a complex, coordinated complex is formed that imparts basically the deep blue color. Okay, and they are good conductors of electricity and decompose at a higher temperature. Clear everyone? That's really great. Now the complex formation, they can even form complex. So complex formation is favored by, who can create complex? The one which has a smaller size, highly charged ion, and suitable empty orbitals. They does not contain any d orbital, no? So empty orbital. So alkaline earth metals, ions not having these characteristics do not have a significant tendency to form, right? Clear everyone? Now see students, coming to action of water, they can react with water forming hydroxides basically. So these metal react slowly with water, liberating hydrogen and forms metal hydroxide. The reaction with water becomes vigorous on moving down the group. And again about beryllium, beryllium does not react with water. Magnesium reacts only with hot water, while other metal reacts with cold water. Clear everyone? Okay, ma'am. Now comes the nitrogen part. Now in the alkali metals, only lithium was forming the nitrite. But over here, as you can see, all the elements burn in nitrogen forming nitrites. That is M3N2. Again speaking, M basically is alkaline earth metal, have +2 charge. Nitrogen has -3. So what are we going to form? It is going to be M3N2 kind of nitrides over here. Okay, which reacts further with water to liberate ammonia. So for example, if you have calcium, calcium reacts with N2 with form calcium nitride. This one further reaction with water will liberate your calcium hydroxide and ammonia. Important reaction. Very, very important reaction, this one. Clear everyone? The action with nitrogen. Coming to the uses of alkali earth metals, that is going to be the last part. Beryllium is used in making electrodes of neon sign lamps. It is also used in the preparation of alloys with Cu. Okay. Moreover, if we'll talk about magnesium, it is used in manufacture of alloys like, okay, magnesium. It is also used as a reducing agent in the preparation of boron and silicon. They form amalgam with mercury. In the previous case also we did that, right? And alloys with other metals. Next, copper beryllium alloy is used in the preparation of high strength spring. Metallic beryllium is used for making windows of X-ray tubes, right? The next part is magnesium ribbon is used in flash powders and bulbs, okay? And MgCu is an ingredient used in toothpaste. Calcium barium metals react with oxygen and nitrogen readily, okay? And radium is also used in radiotherapy technique that is used in the treatment of cancer because it is a radioactive element though. So everybody just write down all the uses that we have written over here. Yes, now comes 2 more homework questions for you people. This is the 3rd homework question for today's class. The question is, the most electropositive amongst the alkaline earth metal is what? Beryllium, magnesium, calcium or barium. Clear? The next homework question is, 4th homework question, that is, alkaline earth metals, barium, strontium, calcium, magnesium may be arranged in the order of their decreasing first ionization potential is what? First ionization potential 2 is to remove 1 electron, okay, from the outermost shell. So let's see whether you know the answer or not. We'll be discussing these homework questions in the next class with more questions, and we'll be ending in the next lecture this chapter. Please read it from NCERT, and we'll be practicing more questions in the next class. So till then, keep smiling, keep learning. Thank you so much and have a good day, my dear students. Thank you.